Good morning, guys. It is April 30th, 2020. Our focus question for today is how do I use the difference of squares theorem to factor a polynomial? How do I know if I factored it correctly? How do I know if I factored correctly? So let's first talk about difference of squares theorem. Remember, our difference of squares theorem states this. If we have a polynomial that is written in this form, a squared minus b squared, and we factor it, the way we factor that is the theorem says that that's going to be factored into the quantity of a minus b times the quantity of a plus b. Now, because order doesn't matter, we could also switch that around and write it this way. Order does not matter in multiplication, right? So this would also be equivalent, the quantity of a plus b times the quantity of a minus b. So we talked about the power of factoring. Remember, if we have a polynomial written in factored form, then if we were solving an equation with it, we could use zero product property. That's why this is an important tool to be able to factor. So now let's go back to this problem here. And I want to show you how you can know if you factored correctly. So I'm going to factor 6x squared minus 9y squared. Something I want to point out, I saw this in some of your work. Because the x here is squared does not mean the whole term is squared. It just means the x is squared. So if we're using the difference of squares theorem, remember, we want the whole term to be squared. So if I'm rewriting this into the form of a squared minus b squared, I need to do it like this. Something squared minus something else squared. So how do I write 6x squared as a number to the second power? Well, in order to do that, we need to take the square root of 6x squared, and the square root of 16 is 4. Let me make this a little bit bigger so we have room to write. Let me make this bigger. So I'll actually do it down here so there's room. Okay, so what is the square root of 16x squared? So the square root of 16 is 4. I see some people in their work writing it as 8 just by maybe dividing 16 by 2, but what times itself equals 16? It's 4. And what times itself equals x to the second power? That would be just x to the first power. And let's just test it. So we're saying 4x to the second power is the same as 16x squared, or 16x to the second power. 4x times 4x, yes, it's 16x squared. Now, 9y to the second power. What times itself will give us 9y to the second power? That is 3y. So if we're writing this out, remember our a value is 4x, that's our a value. So that's our a value, and 3y here is our b value. So now we're just going to rewrite it in factored form, and if we do that, it's going to be a minus b, or 4x minus 3y. And then a plus b, 4x plus 3y. Now, one way you could tell if you did this correctly is just go back and expand it. Because we're saying 16x squared minus 9y squared is the same thing. It's an identity to the quantity of 4x minus 3y times the quantity of 4x plus 3y. So I could expand this to see if I factored correctly. So when I'm expanding or multiplying, I have my expansion boxes. Here's 4x minus 3y. And here's 4x plus 3y. And as I'm doing this, 4x times 4x is 16x squared. 4x times 3y is 12. xy. 4x times negative 3y is negative 12xy. And 3y times negative 3y is negative 9y squared. So we're going to notice this. These two are like terms, so we would combine those, and since they're opposite, they would cancel each other out. 12xy minus 12xy is 0. So what we're left with is, if I combine these, 16x squared minus 9y squared. Notice we went to the original expanded form polynomial. So we know that they are equivalent and we factored correctly. All right, so let's take a look at two problems from your problem set yesterday. X squared plus 16. So this is what I saw a lot of this. I saw people factoring that as, let me erase this. I saw a lot of people saying, oh yeah, I got that. That's the same as x plus 4 times x minus 4. Now, all right, let's see if that works. Let's expand it and see if we get x squared plus 16. So if we do that, here's x, here's plus 4, here's x, here's minus 4. This is x squared, this is negative 4x, this is 4x, this is negative 16. Combine like terms here. Here are my like terms. Notice they're opposite, so they'll cancel out. And what am I left with? X squared minus 16. Notice that is not the same as x squared plus 16. Therefore, the quantity of x plus 4 times the quantity of x minus 4 is not the same thing as x squared plus 16. So, my question to you is, why does the difference of squares theorem not work for x squared plus 16? Think about that. That's right. This is not a difference of squares, guys. There's a plus sign there, right? This would be a sum of squares. The factoring, the theorem does not work if you're adding. It only works if you have a difference of squares, okay? So if you encounter a difference of squares and you're asked to factor it using the difference of squares theorem, if you have a sum of squares, if you're adding, it will not work. It does not work. This tool will not work for this, okay? So just gonna erase this here. And so if somebody asks you to factor x squared plus 16 using the difference of squares theorem, you would just say impossible. Can't use difference of squares theorem to factor an addition polynomial. All right, so let's go to this one. X plus 3 to the second power minus 1. Now, notice this is subtraction, so we could kind of write this as a difference of squares. This first piece, or this first term, is already written as a quantity squared. So if I could write 1 as this quantity squared, so this is how I'm going to write this. X plus 3 squared minus something squared equals 1. And it turns out the square root of 1 is just 1. So let's think about this. Here is your a value. Here is your b value. So let's rewrite this as the quantity of a minus b. So if we did that, it would be x plus 3 is a minus b, which is 1, times a, which is x plus 3, plus b, which is 1. Now, I could simplify this. What's 3 minus 1? I could rewrite that. It's x plus 2. What's 3 plus 1? It's 4. X plus 4. So that means this guy down here is the factored form of this polynomial. They are equivalent. So what is going to happen today, guys, is this. You have a exit slip. Please share your answer with me privately in the chat. So I want you to factor 9x squared plus 25 using the difference of squares theorem. Please put your answer in the chat. And then today, your problem set will be a quizzes lesson where you're going to go through a problem set and you are going to practice the difference of squares theorem. So make sure when you're done with that, you click that you turned it in on Google Classroom so that I know, so you'll get credit for it, and then I'll be checking the quizzes so I could see how you're doing and whether or not you are demonstrating that you understand this concept. Reach out if you need any help. You guys are amazing. You're doing a great job. Keep it up. And as far as tomorrow's concerned, tomorrow will be Friday. Last Friday I did put up a lesson, but I did tell you that Friday would be a catch-up day. So this Friday I will post the video just to share any feedback that I have for the week. But you will not have an additional assignment. There will be an extra credit assignment if you choose to do so. So we'll continue to use Friday as a catch-up day just to make sure everybody is getting their work done and getting their questions answered and really looking at feedback, correcting any work that needs to be corrected. Remember, I'm going to send you back feedback on all your assignments if you're showing that you still need some help around any particular assignment. So remember, just update that, look at that. That's going to help you learn. You don't have to do it perfectly the first time. That's, that doesn't happen all the time in life. So it's okay. I'll give you feedback, learn it, and demonstrate to yourself that you have it and turn it in. You will get full credit. All right, guys, you're amazing. You're awesome. Keep it up. Talk to you tomorrow.